assurance of models. Yes, that's a big one. Port tagging, adaptive components.
Crap, I just realized I wasn't recording. I just started now. So at least we're capturing this slide, which is some good information.
Yeah, and we can send this out. We'll have this part recorded too. We can send it out if you're interested.
Oh yeah, cool. Yeah, that'd be nice to have.
Okay. All right. So next question is about experience with generative design in Revit. So this is a new tool that's out as of 2021. I know a lot of people haven't upgraded yet. Many of you are on the forefront though, so haven't tried it yet. Lots of people tried it once or twice. Some users. Cool. All right, so my next question is similar to the Dynamo questions, but what specific use cases do you use or would you like to use in generative design? Conduit routing, spatial packing, more data viz. And when you're saying analysis data viz, what kinds of things are you analyzing? View analysis, like views from a building or from a certain space? Okay. All right, now I'm going to stop my 20 questions and we'll talk just a little bit. It sounds like a lot of you are familiar with generative design in Revit, but I'm just going to go through kind of what our perspective is on it. And then Colin is going to give really a deep dive into a specific use case that he's been investigating with some of our customers. All right, so generative design in Revit. So with generative design for Revit, we've put access to these tools to do automated design exploration inside of Revit. So it's really easy to access for a lot of people. And you can create these automated studies of looking at designs and analyzing them for certain goals. So here we're looking at the massing of with retail and apartment space, residential space above, and what are the, as we lay out this building different ways, how can we measure the value and the different things that we're measuring about this design? How much of it is outside the zoning? That's another example. So generative design workflows are really based on conversations between stakeholders. And the explicit definition of how to measure a project's success. So they're all the realization of the aligned expectations for success, and it's important to have a lot of voices coming together and discussing what success means, right? So from those conversations, there's a technical workflow, whether it's a large or a small project, followed by the model of implementation. So not that different from the traditional design process, perhaps. But here we, working backwards, we are looking at certain performance goals. So we're measuring certain things about this design. We're evaluating the designs to be able to get those goals. So in this case, we're looking at just measuring the surface area and volume of these little configuration of these 3 boxes at the bottom here that make up a building mass. And we can generate that geometry into all these different configurations that we can then measure and study. And of course, we are having different inputs to make our different designs. And we can constrain them in different ways. So once a new workflow is created and modified, it can be shared with teammates through a simplified interface in Revit. So you can customize, these are our kind of Autodesk samples on the left, and you can customize it to make your own generative design folder, maybe a shared folder, and share that with your teammates. any user can then deploy these workflows directly in Revit and customize the outcomes to their goals. The thing that's important to emphasize here is that it's really about goals and about how can we as designers and engineers be very clear about what our outcomes are and how to measure those outcomes. So once the designs are executed, users have a variety of visualization tools to interrogate the resulting data and narrow down options based on that information or additional criteria that they may discover along the way. So it's really a tool for automating design exploration and also keeping track of all those designs that it's making and helping you analyze which ones are going to meet your goals. All right, so a little bit about who is using generative design in Revit, and I'm going to go through these kind of quickly because I want to make sure we get time for Colin to tell us, get into more of the weeds here, but just some about who is using. So we have a lot of students and universities that are interested in developing how to use this technology. And this is one of my favorite examples out of University of Toronto. They were looking at coastal resilience and thinking about how to look at parcels of land and evaluate them for how you could build on them in order to make the most value on the land, but also to reduce the flood risk. So as sea levels are rising, the kind of one size fits all zoning methods aren't really working for evaluating these land parcels. So they wanted a better way to do this, and so they were able to quantify things like the value and the flood risk, and then test out all of these different scenarios. This is another example. Stamhuis is a architecture firm in the Netherlands that does a lot of retail design. And in this case, they were looking at the layout of a liquor store. And so they're looking at things like, what can I see from different places in the store? Where should the cash register go? How should the different shelves be laid out? And they were able to invest in kind of learning how to script this in Dynamo. And then they said that it really was saving them a lot of time to look at all of these different layouts that their script was making for them. And then this is an example of actually using the design technologist making a script and then using it by designers in generative design in Revit. And what they were doing here was taking these shell forms and rationalizing them into how would you build this out of metal pieces, and how would you build it out of metal pieces so that we're using the smartest number and we have the least waste in all of these, how we're constructing these shells. So the designers were working on kind of, aesthetically and other considerations that went into where these shells were placed and how they were shaped, and then they could run these routines, which would then allow them to optimize how it was going to actually be broken into these metal pieces. So with COVID, goals around occupancy in places like offices and restaurants have suddenly and drastically changed, and now are suddenly and drastically changing again, right? And one of the AIA recommendations is simply lowering density and staggering workstations, which really should be automatable. And people aren't necessarily throwing out all their furniture, but they're trying to make these different plans of where to sit. And so this is a method to find an arrangement of existing workspaces that flags some of the desk as usable in green, and looks at different ways that you could lay that out with different target occupancies. So in this case, looking at up to a 30% occupancy. So this works by feeding it an instance of an office chair from Revit, and then it finds all of the chairs that are the same, makes a list of them following a generated path, drops half of them, measures how many of them are 6 feet apart, and then colors them green. So the routine shifts the path to find ones that yield the highest number of good chairs, up to 30%. And some plans have multiple optimal configurations, while others have a single outcome. So this is definitely an example of something that's great to be able to use the computer for, because doing all of this manually would be very tedious. So this brings us to the main topic tonight that we're going to talk about. Colin's going to go through more depth in thinking about some of these workflows that have been inspired by our current situation. So I'm going to stop sharing and hand it over to Colin, if I can find the stop sharing button. Sorry.
I might just do start sharing. Does that work?
There you go. Okay.
Cool. Thank you, Lilli. So anyway, this is where I got to enter the picture to try and figure out, to work with a team a little bit for a few months to just work on over the last summer, helping just flesh out some ideas. The neat part about that this particular problem, even though it's less maybe directly germane these days with higher vaccination rates and things like that too, and there are a lot of parts of this problem that are directly applicable to other problems that will persist for a very long time. So anyway, one of the part I really like about it is that if you look at the way that Lilli just showed that particular algorithm working, the original team that came together had several different ideas about how to approach the problem. And there's this issue with the generative design that you want to make sure that the Dynamo script you're writing is sampling the design space smartly. And, you know, like of all the different variables that could affect these things, and the two principal sort of axes to sort of have this Dynamo script like move around on would be, one is which seats are being occupied and which seats are not being occupied, like that pattern. And then the other one is where the seats are. Like, you know, if you had a big room and you had 3 seats all the way in one corner, you could say, well, they're too close together. And one answer could be move the seats, right? So like away from each other. That aspect of that manipulation, that manual side, we decided to say, leave that for the human. That's just going to be, we're just going to operate on whatever the model is in Revit, and we're going to give an answer and move other things around. That left the problem to be something like, given an office layout or a school layout, how do you optimize for that, the maximum density given a minimum separation? And so we started there. So I want to talk about exactly that last one. So for example, take this example, office floor plate. And I want to show you one of I like this idea. The idea is originally from Zach Crone. That looks at how to actually go through this. The neat part about this is that the script is not too complex. That's one of the best parts about this. Like, you know, it's got some inputs and outputs, and then there's like some number at the end, and you've got a couple numbers, and you can like run through all the different generative design options because you can measure things. But I was interested in more, I don't know, academically esoteric, pure version of something, or something that would sample that design space a little more thoroughly. So I just wanted to start off with, I want to show you one of the really cool ways that I really appreciate the script for, because of how the logic behind it. So what Zach was after when he says, how can we do this really quickly, was basically, how do you get a couple of knobs that you can fiddle with, that basically you can let Revit Generative Design fiddle with, so that you have lots of different patterns that you can operate on. So the way he did this was he made a really big squiggly line that goes across the whole path. So I don't know if you can recognize this, but this individual floor plate right here is being represented in the Dynamo script. The instances of the chairs are basically their placement points are being pulled out here. So this is sort of like, imagine a super abstracted version of the floor plate. So the points are the seat locations, because that's where a human would generally be spending time, and then the green are for this particular iteration they've chosen. But this is the mechanism by which that happens. So I'm gonna now turn on the preview for one of these components here. So this is so cool. This is the one way like that Zach and I have always enjoyed this. Though our brains work very differently. His works in this way like this, which is like super direct to the point sometimes. So what this is took the whole bounding box of the whole thing, drew a big circle, and then divided the circle evenly and just started doing like zigzagging points. So you can do with this is you can toggle. One of the toggles is how dense the zigzag is, and so you can like make this less dense or more dense. And then another thing you can do is then rotate that zigzag. And the purpose of that zigzag line is that it's like this armature that organizes all the chair points. So the Dynamo can walk along this curve and find out, and sort of like grab all the different chair points and then suck like right to the closest point on that line and then order them and then pick every other. And then so that's one way to get to something like 50% occupancies, because you're randomly picking which every other. And the two knobs that you fiddle with are one, the density of this line, and two, the rotation. So kind of cool, right? All right, so there. So that's kind of neat. But then it tends to lead to this problem where now between these two things, you could conceivably get to a very large part of this design space. But then you end up getting some edge cases like this. Like, for example, even just looking right here, you can see that there are some seats in the corner over here, and certainly one of those would have been occupiable. But the way that this was sampling things was sort of missing some of that. So I had the chance to say, like, tabula rasa. All right, how is another way to do this? All right, so now I want to talk through a little bit about a different method. There we go. All right, so I was after ultimately, how do we get something that looks like this, which was at the time, especially the beginning of last year, the summer, were the types of floor plates that everybody was making manually. So you'd go around and say, like, which seats, if you can kind of see in here, this is what's an easy one. Here's a conference room right here. There's a table, and then there are 6 chairs around it. So if you need at least 6 feet between people, then a 3-foot circle around each person shouldn't touch. So and then you can fit 2 people in this particular room. That's optimum. So that's what a human might do, right? And so the issue is, how do you get something out as an output where most of the cases that the Revit Generative Design is generating are something that are reasonable to a human? Okay. So started like this and started to break down the problem. And so in this case, you can look at all the different kind of chair types. So then there's always an issue of how do you distinguish what is a chair, or where is somebody going to sit versus something else, because it's not actually otherwise known. Everything you can say that something's at least the category furniture, but how do you know you can't sit on like a table? So anyway, there's some selection mechanism to say what family types or things like that, and there are a few options we talked about in the blog post. But one is, once you figured out which family types you're interested in, get the bounding box and get the midpoint of the bounding box. And the reason for that is that you can get rid of issues of like, oh, when I modeled my chair family, I put the placement point on the left-hand corner, and then you messed up all the calculations. So at least this, you can run through and automatically get all these center points. So next, you can start to group the center points. And this point, you can do it by room. And the neat part about this is that, say, for example, in this case, there are these like phone booths in this office layout where and each one has 1 seat inside of it. But the seats themselves might be right up against the wall between one another, but they should both be occupiable because they clearly don't exchange air. So there you go. So one way to do it is to start to break down and separate the problem is just by room. So the first thing to run through, and so you're taking all these different blue points, which each represent a possible seat location, and then dividing it by room. Then this is where, so then there's a routine that I wrote, and some of these things had to be in Python and used as sort of custom nodes. But then the next thing to do is to realize that there are still more separable problems, because even within, say, a large room, like an open seating, there are banks of desks, and they're actually findable as independent separable optimization problems, because if they're farther than 6 feet apart, it doesn't matter who's sitting over here, any seat over here would be fine. So that way that the way that Dynamo can go through and then figure out where the optimal seat locations are, you can optimize for individual cases like this. So basically take this whole problem and is reducing it down to these groups. So let me zoom into one of the groups. So I'll pick this one here where there are these 5 seat locations. And then the algorithm does this. So walks through and says, okay, so for any given seat location on this first diagram on the left, look at the 3-foot circle or whatever that input radius is. It could be 1,500 millimeters in Europe. But whatever that number is, you can see that it overlaps. So seats 1 and 3 couldn't both be occupied. But the point is let's start somewhere. So pick one. So let's randomly pick number 4 and say, okay, if 4 is occupied, well, now we know 3 can no longer be occupied. And then you kind of look for like, well, what's next? Then you go for 2. And if you start with 4, you eventually get this pattern. And the neat part is that works a bunch of ways. So of all the different ways to take any one group and then divide it up, it turns out that there is actually a much smaller number of possible solutions. In this situation had only 2. One of them is clearly better than the other. So ta-da, there you go. You've solved your problem. This is one way to do it. It didn't matter which desk you sort of started at. You could start at number 2, and then you could eliminate 0 and 3, and you basically have your answer. So this is one way to go about doing this. The Dynamo script looks something like this. There's some Python in here, but it's reusable, in different generically components. A lot more complex and took quite a bit longer to figure out than the original, but they still give at least some results that are parsable, right? The neat part about this was that this was actually gave pretty good results, and it could be used just pretty much straight up in Dynamo Player because it's just a single objective that it's after. So give how densely packed can something be, give it some input, and then say, yes, I want that output displayed, and they have your answer. It didn't matter. It could be arbitrarily complex, whatever you threw at it, and then it actually runs pretty quickly. Which is kind of neat. So anyway, got to publish this as a blog post last summer. And so it was kind of fun. But, right, so that's not the end of the story, because then there are issues like, well, some of these seats are, you can have it optimal in one sense, because you could take this and find that, in this fixed seating location, you could have 17 people in here. But it turns out that there might be a better way to have 16 people that's much safer. Because if somebody has less exposure to sitting right next to this open door where all the air is going in and out or whatever. So the next question was, okay, how do we take this and then add other criteria that weren't otherwise represented? All right. We get to the multi-objective optimization, which is exactly what Revit Generative Design was built to help look at. So the question then is like when you don't have an optimum, and there's no answer, you can use this whole system to try and figure out a set of best performing. So here we go with that one. To start again with our floor plate. And now what we wanted to introduce was looking at spatial analysis. And there was quite a bit of prior work that I was able to take advantage of from like the Autodesk research team that came up with in the Autodesk University. What was that? I don't even remember what year that was. 2017, something like that, where like the layout was used relative similar to the Toronto office scripts that were published. So anyway, I got to use some of that and a package that team had developed to try and actually apply this to Revit. So here's what we had to do to take this problem, to use spatial analysis, like walking paths and things like that, and make it generally applicable. So the first thing is to take this lovely floor plan, which looks great to a human eye, and then try and make it make sense, simplify it. And what is really ultimately after is a really simplified version like this. And I don't know about you, this is probably not obvious how ridiculously difficult this particular threshold of achievement took, but intersections and bounding boxes. Anyway, this is pretty well figured out and you can copy it and use it. Paul, did you have a question? You ever say?
No, you had just froze for a minute. I didn't know if I had to jump in.
Okay, cool.
Yep.
It probably wasn't important anyway. Anyway, so and what this is basically going to be is this is going to be a set of barriers. So for the simulation of given where people are sit when they stand up during the day, and maybe once an hour they go to the kitchen or they leave or something like that to try and simulate traffic, all of these barriers, the simplified floor plan are going to be obstacles. The next thing is to figure out furniture, because you can't walk through furniture, and certainly we're interested in seats. So the next thing to do is identify a set of seats. So here they're identified as being, like these blue circles. They're simplified, but this is again ripping out from that same Revit file, and then identifying everything else of the furniture category that is not a seat to be an obstacle. And then the other neat part here is, according to the space analysis package, you can give start points, and then you walk around obstacles. But there's no it's line based. So there's another aspect here, and this is the kind of, massaging of some big script that actually eats all your time. But for example, if a chair is modeled as being pushed in underneath the desk, then the center point of the chair is going to be within the boundary of the table. So as projected down. So if you didn't pull all the chairs out from under the desk in some automated fashion, then you'd have traffic that would be confined to your conference table. So that's a bunch of vector math, but that's in there too. You can rip that off. And anyway, took all the chairs and pushed them out. And then so basically started with something like this. So now we have our setup for the spatial analysis, which is different from the just a single objective of like most highly dense packing. All right, so then this is kind of cool that this is quite literally right from the spatial analysis package, and it works fantastically well. So what I did was I selected basically these doors as there are 3 of them here, but the script is generic, so you can add more or subtract. And then these are basically attractors. So from every seat that would be occupied, then there are paths to each of these places. And then as that builds up in the kind of histogram, you can get a sense for where the traffic really goes. So even though there is no such thing as a Revit object that's telling you what the hallway or the implied hallway is between floating desks and an open floor plate, you can actually find it this way. So you can take this and then in the background, build this up as a heat map. So ta-da. So now we have a pixelated version that can just take this office floor plate with no other objects, just the obstacles, and then identifying where the higher incidences of people walking by and having traffic. So that's the green color. And this is normalized so that there's always a lot of, you can pretty much tell, you can kind of squint and see where the aisles are. Then we can take this and then reverse engineer values per individual seat. So of all the seats that are now appearing back on this diagram as circles, then you can actually figure out of these, which seats are the most exposed to standard traffic. So you can, the ones that are now colored in as being darker blue have a much higher exposure to people walking by frequently than ones that are, say, white. So if you're off in the corner over here, nobody's walking by, it's pretty great, but there's much more airflow around here. And herein we have another value per object or per seat that we can use as part of an input to trying to figure out not just is the seat too near my neighbor, but is it too exposed or not? At that point, we can use that information and maybe set a cutoff. Like maybe the cutoff is some level of exposure is unacceptable, and then those seats are no longer allowed to be occupied. The consequence, in fact, you can see in this particular one version of what this algorithm would produce, that there's a set of these seats that are down by this hallway, all of which are sort of don't sit here, even though you technically could make this occupiable spatially. But again, this had a higher exposure rate, so it was cut off. And then it's balancing these things going back and forth. And so then, so these are the inputs, and then this is what a version of the output would look like. And then the only other thing you need for Revit Generative Design or any kind of optimization routine really is the issue of being able to assign a numeric value that you either want to maximize or minimize. So you can actually have some as like that's better or worse as a yes or no. So there were three metrics that were used, each of which corresponds. You can actually calculate that metric like per point. And then there was a way that actually the Autodesk research team came up with, just like sort of summing that to a number. This would be representative of congestion, or that traffic pattern I talked about before. This is a little bit derived from that. So like given an occupied seat, this is the exposure to that traffic. So if you're sitting in the yellow areas, for example, that's like among the seats, and actually it's a little abstract, but this is the exposure to the traffic, a map of that. And then finally, this is an idea of looking at where the higher hotspots are, where the seats, when chosen as an occupying pattern, are more dense. So this is always normalized. Red isn't necessarily bad. This is always going to be red, but it's a way of seeing the difference. So anyway, around here, there's still some clumps. There we go. And then from there, we can jump into seeing what this looks like in Revit. So, or in Revit Generative Design. So I think this part's kind of fun because this is the And then Lilli, I'm going to want your help walking through some of this. But one of the parts about this is that once you get this far, so you have a script that works and it gives you some results, you can learn things. So this first one, I want to show this guy. This is an example of an output. So this was a study that I did based on basically this algorithm. And you can see various different outputs here. And there are a few ways to visualize this. So one is, what is this called? Spider plot?
Parallel coordinates.
Parallel coordinates plot. So this would be all the different inputs or things that are measured. And then every given line that connects these represents one particular design iteration. You can see total seats in selection. Of course, they all had the same number of seats. So they all had exactly 103, I guess, in this case. But then there, as measured, there are ones that had higher exposure or lower exposure. And there's some correlation here. One of my favorite things, I don't know, as just being a teacher, or at least part a teacher, I like playing with stuff like this because I was like, this was my aha moment. So of the different things you can sort of plot, since the human mind really can only deal with 3 dimensions at a time, or at least mine can't, and there's a way to just simplify and just compare 2 things at a time in a chart. So you can look at, okay, each of these dots here represents one of the design iterations that came out of that fell out of this chart, while toggling, again, those inputs being like, how close can the seats be to one another, and what exposure level are we willing to tolerate? And just between those 2, all these things fell out. And so here, just randomly selected some of these. But and right now they're falling on a straight line, and that's because by default I was looking at the y-axis is what the percent occupied is, and the x-axis is the number of seats occupied. But like obviously those are always going to go together. So what we're going to use instead, we'll look at something that we actually wanted to calculate. This would be the dependent axis in physics. So if you look at the exposure rating, so now it's taking along the x-axis. This is the looking at the number of seats occupied. So down here, there's some kind of version here that only has 30 seats occupied. And there are versions up here that have more, well, I guess that's 85, 86 seats occupied. So much denser. But then there's an effect that translates to how what the congestion rating is, and you can start to see that there's a curve here, and curves are exciting. So in fact, what's called the technical term is Pareto front, and what that is since here's the issue in multi-objective optimization, you can't get everything you want. You can't have both the maximum number of people in your office and also the minimum possible exposure to other people, right? You can't have both. So what you're trying to do is find out something that's acceptable. And the highest performing of those results all tend to lie along this kind of cool curve, this Pareto front. So anything that is like the lowest possible, so the lowest along this curve, meaning that you have the lowest exposure and then the highest number of occupancy. Anyway, anything along this front right here is gonna perform far better than anything inside. This is sort of random chance. Anything up along here is a much better option. The next thing to say is that there's another way to generate this too. The way that I generated these, and you have to sort of like keep this in your head for a second, what this chart looks like right here. You can kind of see there's kind of a clumping inside. Again, I can go to any of these and then see some consequence, to what exactly that looked like. But there's this, some of these are, by good guessing, got pretty close, but not a whole lot. The way that I was asking to go through this made just 40 sets of guesses for those 2 numbers that were the inputs, like minimum separation between seats, and then also the maximum allowable exposure rating. Another way to do it is to set to actually try and optimize something as opposed to just randomly guessing. And this would be the way that this is set up, is that actually, I'll show you how to set that up in a second, but I want to show you that the difference, if I look at the same kind of thing, exposure versus the number of seats occupied, I have far more results to choose from that are up against this edge. All of these are great results, and I have far more things to choose from. So if I wanted to say have, in this particular case, I'm choosing this option, this correlates to 78 seats occupied. I could choose something else that had 78 seats occupied that had worse exposure, right? So you can actually see there's already something that is demonstrably better that's measurable between the two different layout options. And another thing to sort of point out here too is that in this case, the problem was to make sure that people are more evenly distributed or farther away from one another and not clumped up. And you're trying to minimize exposure. You could take this and apply it to other spatial analysis problems. Like, let's say you had an office layout and you were trying to figure out what's the minimum, what is the minimum number of garbage cans that I could put on the floor such that nobody has to walk too far to get to one, and that you would want the garbage cans to have the highest exposure, like, easiest access to like a hallway, right? So you could take all this same logic, and then instead of minimizing exposure because you're trying to make the people be away from each other, you could say want more exposure to like signage or trash cans or things like that. And it's all like basically the same algorithm underneath. Any things I should, before I talk about the graph itself, I want to stop there for questions because that was kind of a lot. Or Lilli, I'd love to, you want me to help point out things that I missed here?
No, it's all good. Yeah. If you have any questions, maybe just unmute yourself and ask, or you can type them into the chat.
Colin, did you generate those image files, or did Dynamo do that for you?
In this guy?
Like these heat maps and stuff. Yeah, those guys. Yeah.
That is 100% Dynamo.
Really?
Yep. And in fact, I'll show it to you.
All right.
All right. So I'll take the challenge.
But we really need to work on our on our data viz in Dynamo and in subsequently in generative, because as you can see there, it's really hard to see a floor plan.
It is, and it's also big scale and things like that too. So I'll show you that the kind of one of the things, by the way, about this project that I particularly appreciate is that I'm not a stranger to these ridiculously large projects that are very complex, but this is the first one I've been able to share with people and talk about it. So that's been kind of cool too, because most are highly proprietary for something you can't talk about, right? Anyway, so because of that, and because it was supposed to be, in some ways a teaching example and then distributed, there's also a chance, this is still loading, by the way, this is just really big, it's very highly polished, so all the way through.
I put in the chat a link to the blog post where you can download these scripts and check them out. And as Colin says, steal parts of them.
Yeah,
please do.
In case that's interfering.
That's fantastic, and I'll make sure I add that link to the post after this meeting too, on the meetup.
It's always challenging to kind of open somebody else's Dynamo script and try to understand it, but well, Colin will show you now. Like, we try to put notes in it and explain it. He has good grouping.
Yeah. All right. So let me just run this. Any one run is little. There's a lot in here. But it's very well documented, so you can run through. The groups are all organized, and I have some notes I want to share too at the very end about how to deal with large graphs like this, because you just can't. I mean, be cheap about the documentation, because you go away to lunch and then you come back and you're like, you have to help yourself even sometimes too. I am quite sure, by the way, that this is using the same graphics card, so this is the reason this is taking so long, is because I'm also on video, because that does not act like this if I'm not. Anyway, while that's loading, let me run through the last couple slides I had here, and then we'll come back to this.
Your point about the documentation is so well taken. I mean, I find that I'm often documenting as much for myself as for anybody I might share it with. So
yeah, totally. So there were a couple things that I picked out as being particularly important of these, so I figured I'd run through them. So one is that there's the large graph, this mega graph is organized in like basically these three phases, and I think they represent somewhat like how you should think about generative design problems. There's some setup, and the setup can be complex, but that is all in just Revit stuff. If that was largely just picking out the right chairs and making sure you had the right and center points and making sure you're dealing with curtain walls differently from a basic wall and like all kinds of things like that. And then the analysis part was just like what I ran through before. And you can see it's kind of a minority of the script, like a lot of it, and the rest of it on the back end is sort of that data visualization because it was on the complex side. But so anyway, here's a few things that I used. I had some standard for what the group colors were. So I said I marked what those are. So if it was touching Revit, it was always blue, and if it was normal, it was green or whatever. If I ever got something from, like, if I used a package, since this is not particularly well highlighted in Dynamo, and if I just always make sure I note where I got something so that you can find it again. I used this.
They have made some improvements to that.
They have, good.
Yeah.
Good. Excellent. That's a holdover then. Then I'm like one of those crusty old CAD managers. Like I'll just be doing that forever, probably.
It's a good practice. It doesn't work.
Yeah. Another thing I do is I collect things. I have these like pass-through variables, since code blocks can take text, especially if anything goes more than one place. As sort of an input to a group, I'll label it. So I know, like, oh, there are the seat elements, or type thing, or the seat points, or the seat bounding boxes, or whatever. And that's true.
I like to do that too. If you have your seats are really far away, you can put it in a little code block node and then drag it way down.
Yes, exactly. You can totally drag it way down.
I know what it is.
I think of those as like extension cords.
Yeah, good. I like that.
Yes. Extension cords. I also sometimes, by the way, since that can actually have a performance impact on very large graphs, because you're copying the data every time you do that, and on most graphs there's never a problem. So other times I will actually sometimes just use a note instead of writing another thing next to it. It depends on it's a little bit of auditing. And then here's like the mega extension cords. So whenever at parts I had like these transmission lines going through, and then like I could pick off things, and especially this is, oh man, this would be unreadable otherwise. So it helps to have something like this happen. Again, there is a performance impact for doing this though, because the way the execution happens. So you have to be smart about where these go, and don't use it a lot. But
I actually didn't really realize that. We should really try to fix that.
Well, speaking as a product manager, I don't know if you should fix that necessarily, because it's probably pretty rare that people like me would be doing things like this. So it's complex. So I don't know. It's up to you. Fair enough. Well, it's not my job. So another one that I was not necessarily as good about before doing this large graph before is if you have more than one output, you've got to put that on there. Like, what is true and what is false here? So I was like, these are seat points with expressionable opposure, and then like out, these are the ones that are rejected. Like, so because it depends on how you ask the question, which one it is. And so I always 100% of the time, if there are two outputs, I will always label it. That's been a big deal. I do this for Python scripts too. For the inputs, I always use these pass-throughs, and even the outputs, this is completely thrown away by the compiler, but because it's really looking at whatever order is coming out. But by writing this text here, I can see what that actually is, and then have the output ports that sort of like together make this variable number of inputs and outputs that are labeled. I always do this, and the other one is that if you ever do anything weird, you have to write it down. So I effectively was making at some point this less nested list, a hugely complex nested list structure, which is kind of my signature. But so what I ended up doing is they was always in this order. So always the first was the seat element ID, then any associated furniture, and then some orientation vector. And it was always in that order. And I made sure to write that so that every time I did that, you can say, oh, the reason I'm going for list number 1 is because that's the associated piece of furniture. And then obviously label your groups. The double slash in code blocks is wonderful. I am a big fan of doing this code out in code blocks like this. But especially if it's something like this, like how would you ever know what this equation actually meant if you didn't write it in English also? So I will always do that. It's pretty cheap. Similarly, in Python scripts, this is super rare that I think anybody ever really does this, but really, it's really important to write down like what you're trying to do with that thing there and assumptions. And then finally, the last two is if you this. So you know how if I love null values. I think they are a data type, and I like using them as placeholders. Most Dynamo nodes do not like null values. Same as for Grasshopper. So like they do not particularly like them, and they think you probably did something wrong. So it tries to tell you, right? So it's gonna say like, there's a null value. I'm gonna turn orange, and like, please over here, there might be a problem. That can be really hard from a diagnosing standpoint later on when you're trying to figure out what's wrong. It's like, well, that something's wrong with that node. Sometimes, based on the logic, it's okay to have something that is throwing null values. And so if that's ever the case, that's the number one thing you should ever mark. It's like, if there are errors going on here, it's okay. Please stop looking further. And then finally, anything, if you ever touch cross-lacing, good Lord, like you have to write that because nobody ever sees that. I don't. So the only other thing to always write. So that's my advice. All right, so now we're
I think we could rename this session Colin's Masterclass in Documentation. That was fabulous.
Thank you.
For all those
It's
tips.
the third blog post, so he wrote it down too. It's awesome.
It was not a part of the scope of work for me originally. I was like, no, the world needs to know. So
yeah, that is so helpful. Yeah.
Anyway, the size. So this documentation it's 100% in here. What I ended up doing for this was having, and it shows how to do this. So the heat map uses basically it's a surface that's shrink wrapped to the size of the bounding box of the area, and then I never remember the name of the node, but it's like geometry, color geometry, whatever that is. But you can give it a matrix of color values, and then that's a nested list, two-dimensional list, so that it'll apply it to that. And then the values of like the two colors, like purple to green here, was just a design choice. And then basically the rest of this was all vectors. So like, given the fact that you had these different things to display, what I would always do is like just stick it in the center of the screen, and then if it's anything related to this this floor plan description right here, then move it up to the left, move the other one up to the right, down to the right, down to the left, and that way this whole thing will always grow or shrink around the origin. So you could use it on a really big file, and it'll be really well organized and small file, and they'll still all be like displayed. And there are a couple of tricks I did to make that a little simpler than it otherwise was. The display itself is all happening at the, sorry, this is super slow with the video on. But the display that's happening over here, I always use the color blue, I guess. And this is what's largely doing that. But I would do things like, I really want to show you this. I also like doing this kind of thing. So even just getting this dot.
Do you want to try turning off your camera while you're zooming this thing?
He's got it now.
I've got it now.
Oh, you got it.
Yeah, it's a good point. I should have probably done that. I got it now. So one of the things I'll also do sometimes is I really wanted to do this, is like get this dotted circle around a point. I like it as a graphic thing. It turns out it's it would take a whole bunch of nodes to do it, or like some built-in thing, but as long as you can do it in nodes and then collapse it to a custom node and then make it a function and then call it right within this. So you can actually just say like, this is sort of like a built-in custom node. So you can like move this file around and not have dependencies of other custom node files to drag along with it. But it also is nice to use English to do this, so say like draw a dotted circle and you know what you're doing. And then you can you can change the radius and things like that. So
totally doable.
Okay.
If you want a circle with an X in it and a dotted line around it, you can have this custom node. Or I'm sorry, that code block. Copy paste it.
Right. So here's ultimately that's the size of the script. It's pretty big. It used to be a lot bigger, and then I had to make it a lot smaller using Python just to make it run within a human lifetime. But think I did okay. Anyway, questions. Love to take questions.
If anyone has a question and wants to unmute, just go ahead and hopefully we won't have people stepping on each other, but we'll manage it. So anyone have a question for Colin? This is fantastic stuff. Oh, come on. Somebody must have a question. They're all just dumbfounded. They're like gobsmacked at how amazing this is.
It's useful too.
I have to admit that the few times I've played with generative design, I mean, I use the sample ones, but I don't think in these spider graphs or whatever these things are called. So I wasn't really sure what I was looking at. And that was one of the things that I liked about the way you explained this is, showing the relevance of some of these graphs. I think that helped me that the next time I play with this, I'm going to have a much better idea of what I'm trying to do with it. Like, it's one thing to run it, but then it's another thing to know what's it for? Like, what do all these dots mean? And, so that was super helpful too. Now, whether or not I would ever get to the level of being able to develop the logic that you put into this graph, well, I don't think I'm ever going to get there.
Well, fortunately, it's made to have parts stolen from it on purpose, so that it's not every time it's not as big a leap. So
I love your comment about Zach earlier too, because I feel the same way every time I call him. His brain works in a very different way than mine does, and sometimes I just need a dose of Zach to get me over a hump. So
I love that. I love that you can turn on the preview and like see how his brain works.
Yeah. It's like those posts that he has of his little plotter in action. That's the first thing I thought of.
Yeah. And I should also end on that note too. Like, not that this should be hugely intimidating, because you can get useful results out of something that's quick and dirty like that too.
And we're trying to make more packages. I mean, that they're not always easy to understand how to use them and put them together. But Colin did use some of the work that Autodesk Research had made in, as he explained, in looking at evaluating the Autodesk University show floor layout, and, reusing that kind of logic for pathfinding and different routines like that. We're trying to build up more packages that are useful in certain kind of workflows that people want to do, so that they don't have to necessarily start from scratch. But it is a very, you see like ways, if you look at, how Colin's thinking about this, how Zach's thinking about this, it's really like, I love the creative thinking that goes into this. And, some people come to us and be like, oh, you're going to kill my job as like automating design exploration, but there is a lot of room for creativity.
Absolutely.
How you think about.
I think the grouping, I don't know if this is a question or a comment. Just the way you talked about how you broke the problem down by grouping the areas so that they were not only more manageable, but I think also because there were different criteria involved, right?
Yeah.
And there's a graph that I work on and off, that I've been working on for months now, that has some aspects of that. And I struggle with how, like, it's so easy for you to look at it and say, well, these things have to go together and these other things shouldn't be involved, but then trying to tell Dynamo that that's what you mean.
Turns out that's actually properly a graph search algorithm that really has to be in Python. And
okay.
breadth first is better than depth first. It's a little more efficient. I've written a bunch of those, but that's not something that would be obvious. But that's a really good candidate for somebody figuring out one time and like just use the result. But
okay, yeah,
yep.
Yeah, you and I are going to have some beers one of these days and talk about some of that.
Deal.
Where are you located now? Are you on the West Coast?
I'm still in San Francisco.
San Francisco, yeah.
Okay. Coming back, and I think this is the 4th time I've moved. Yeah, it's a whole thing. Yeah.
Yeah.
Where were you when you were working on some of this stuff? Weren't you in Tahiti for a little bit when you were
Tahiti,
working on this?
I was.
pandemic
when
adventure.
Colin first spoke for us, he was driving through Chicago on his way to San Francisco, one of his moves, I believe.
Oh, from
right?
San Francisco to Boston, actually. That was one of
Oh, the other way then. Yeah, you were
with my stepfather, and we parked at the airport, took the L end.
Yeah. So I remember that you were on your way across the country, and yeah. So
yeah.
That's outstanding. Well, this has been fantastic. We're at the hour. If anyone has a question, either throw. I didn't actually look at the chat. I don't see any, but throw it in the chat or just speak up if you like. There are some comments in the chat here. Let's see. Some thank yous.
I have a quick question.
Yeah, go ahead.
I really appreciate you sharing this great graph on your blog. I did get a chance to try your script on our case study project, and one question I had was that when we're trying to use the my designer's furniture plan, that some of this furniture had I think that there was some problem with getting the good bounding box from these the chairs. So is there a better way to get how do you say? I mean, what's the best way to get a good bounding box from the do we have to swap out to the different furniture so that you get a better bounding box, or is there some way around it?
I would say there's a node, I think it's element.bounding box or something like that. It might have even been a clockwork node, but it just used, I think that is known. For some reason, it's very quick to get that information, what is the X and Y extent in world space. What it will miss though, that bounding box, is if you had a square table that's on a 45-degree angle, your bounding box is going to be much bigger than that square table will have been, because it's not a local bounding box. It's the bigger, but at least for finding the center point for chairs, that's a pretty good approximation. So I thought that was okay.
Okay.
Yeah, and the nice part is that if you don't get, because you could also do something like this, you could extract the geometry from an element, which takes all the geometry that's modeled in Revit, translates it into design script geometry, and then take the bounding box of all that. But that is much more computationally expensive, and you don't actually need that resolution.
In terms of the efficiency.
Now, isn't it true that the bounding boxes are always orthogonal to the coordinate system?
Yeah, they are.
Yeah.
I wrote a note in ampersand to make bounding boxes that are the minimum bounding box. I'm very proud of that. That took a long time to figure it out too. But also Python scripts do that. But to actually give you a bounding box that is local to the coordinate, so it would turn. But that requires knowing the geometry first.
Right. Okay.
Thank you.
Yeah.
We had a comment that so glad they checked in. They first tried the script on their own and were overwhelmed, but loved the way you explained it. So just make sure you read the comment before you check out later, Colin.
Thanks.
So, yeah, I completely agree. All right. Well, it looks like some folks have already started to drop off. We're past the hour. Lilli, I know you have some other business to attend to this evening, and Colin, it's still a little early for you, but most of us are either on Central or Eastern time here, so we'll let people start getting on with their evening. But that was fantastic. You guys are welcome back anytime. And we got to wrangle Zach back in here. We haven't had him in a while. So tell him we're going to be gunning for him soon. So
totally. Thanks for the invite, Paul. Thanks for the work.
Thank you so much.
All right.
All right.
Thanks a lot, guys.
Cheers.
All right. Let's see. Stop recording.